Hi all, welcome to Unit 1 Physiology. We are investigating the responses of the skeletal system in this video. So the learning outcomes here, we're describing the role of each bone cell and synovial fluid, explaining the skeletal system responses, and analysing that process of ossification and bone remodelling, applying to sports and exam questions. So just pause the video here and discuss the questions below. Right, so hopefully you have looked at these questions. Throughout the lesson, we should be able to answer these in more detail, adding depth to the answers that you have put down. So the process of bone growth then, can you remember this from last year's anatomy module? Pause the video and have a go at filling in the gaps. Right, so the process in which bones are formed is called bone remodelling or ossification. Cells that remove unnecessary calcium are called osteoclasts. Cells that bring calcium to the bones are called osteoblasts. Okay, and the end of each long bone containing a specific area that allows the bone to grow longer. This area is called the, can we remember that one? Epiphyseous or epiphyseal line is our next one. Okay, so epiphyseous, so they create that line, and we've got here, once the long bone is fully formed, that would create and fuse the main shaft to create the epiphyseal line. I apologise for going back there. So, in overall then, we're looking at this process here. Okay, so activation, reabsorption, reversal, formation, and quiescence. So just pause the video, have a read of that process again, and make sure you understand each detail. So bone remodelling generally is a mechanical stress, okay? So if we are exercising, that will produce a mechanical stress leading to strengthening and thickening of the bone, and that's known as Wolff's law. So exercise is weight bearing. Like I said, it produces that stress or places the stress on the bones when the muscles are contracting. And long-term exercise can slow that skeletal aging. So pausing or slowing down the process of osteoarthritis. Okay. So the roles of the bone cells, these are the three bone cells we need to be aware of. We've got osteoclasts, blasts, and sites. And a top tip to remember them, try and remember osteoclast, that C stands for clear, osteoblast, the B stands for build, and osteocytes, that C stands for control. So a couple more details that you need to be aware of are the following. So we know that weight-bearing exercise suppresses osteoclast activity, okay, meaning that the bones aren't breaking down as quickly. So under stress, that osteoclasts are stimulated to clear more bone tissue, removing calcium and transporting enzymes, okay, and this stimulates osteocytes to build bone, okay. Osteoblasts, they're immature cells. They produce a matrix to become mineralized, and when loading the bone, calcium in the blood is absorbed and encourages bone formation. So in turn, these osteoblasts deposit minerals and collagen fibers to increase the bone density. Finally, osteocytes, they control reabsorption and formation, so they become trapped in that matrix created by the blasts, and they direct osteoclasts to areas of bones that need remodeling. So as a summary, osteoblast activity is increased in response to mechanical stress. That's our first response. And weight-bearing exercise is where the body is working against gravity, including weightlifting or running, and any activity that is weight-bearing. This stimulates bone and increases blast activity, resulting in improved bone strength and density. So non-weight-bearing activities such as swimming and rowing, where gravity does not influence the body, that does not increase this osteoblast activity. So an exam question you might see is the following. Explain the role of osteoblasts during bone remodelling. So we're looking for an answer such as this. Osteoclasts break down bone. Okay, you could have said during the reabsorption phase by removing calcium and transporting enzymes. Osteoblasts are cells which form new bone by replacing collagen or depositing minerals. Synovial joints then. So these joints we need to be aware of. There are 5 main joints where it can be found: knee, elbow, shoulder, hip and ankle. The joint looks a bit like this. So we have synovial fluid just above that joint capsule, protecting the bone from friction. Okay, so synovial fluid overall then, it's a thick straw-like liquid, and it is within the inner membrane of a tissue and lines a joint. Okay, so exercise increases the production of synovial fluid within the joint, and this is warmed and becomes less viscous, so it becomes runnier when we exercise. So the benefits of this then: it lubricates the joint, reducing friction between the hyaline cartilage and the articulating bones. Also, it can allow for pain-free movement and aids joint mobility and range of motion. So it acts as a shock absorber as well, which is quite handy, obviously prolonging the amount of exercise that you can do. So overall, for this system, we need to know of the 3 skeletal responses first and foremost. So we have an increase in osteoblast and clast and site activity. Second response we need to know of is an increase in synovial fluid production. And the third one is a reduction in viscosity. So overall, with this lesson, you may be able to answer these questions now. So have a bit of a read of the questions, pause the video and attempt them. Now that you've attempted the questions, this is what we're looking for. So explain why an increase in synovial fluid production is an advantage. This is because it lubricates the joint, increases range of movement, and she can achieve a better throwing technique. What about a reduction in viscosity? Again, lubricates the joint, reduces friction, allowing pain-free movement. Right, so going back to our initial questions, can you now add details to these questions here? Have a go. Finally, what do you now know? Test yourself on the following questions. Do you need to revise, reread, or are you rock solid in these answers? Thank you very much.